Guys, today we're going to be looking at angle-angle similarity amongst different triangles. First of all, we need to know this postulate. If two angles in one triangle are congruent to two angles in another triangle, then both triangles are similar to each other. Remember that similar shapes have two qualifications. One of them is for similar shapes, the angles must be congruent. And then the second thing are their sides are proportional to each other. Okay, so in order for two triangles to be similar, angles are congruent and sides are proportional to each other. So let's look at these two triangles here, and we're going to decide are these similar or not just by looking at the angles. Remember, if two angles in one triangle are congruent to two angles in another triangle, well, I see that 100 here is congruent to 100 here. So far so good. I see a 35, and the angle that corresponds or matches in the other triangle is B, and then I see 45 that corresponds to A. So we need to solve for one of these missing angles. Remember that a triangle equals 180 degrees when you add them all up. So if we add 100 plus 35, that equals 135, and if we subtract that from 180, it should hopefully give us 45 if these are similar triangles. And in this case, these are similar because we have 45 and 45. We have 100 and 100. And I'm very confident that letter B would also be equal to 35. Alright, so let's use what we know about similar shapes, and we're going to be solving for missing side lengths. Remember, two angles in each of the triangles have to be congruent. I see a 95 here and a 30 here. I see a 95 here and a 30 here. So these two triangles are similar. Similar triangles have proportional side lengths, and we are trying to solve for x here. So in order to solve for this missing side, we are going to set up a proportion. Now in our proportion, we're going to try to find sides that correspond to each other, or they're in the same position. I see that they gave us lots of numbers. We don't have to use all the numbers. Let's start with this 4 inches here. It corresponds to 18 inches. Those are in the same position. We have to use the side that's with the x, so we have to use the side that's corresponding to x in the larger triangle. So let's go ahead and plug in our numbers. Remember that 4 and 18 are corresponding, so I'm going to put those in the first fraction together. We're putting the smaller triangle up top and the larger triangle down below. So x, or our missing number, will go up top, and I'm just going to leave it an open box so we can fill in our answer when we solve, and it corresponds to 31.5. So we're going to use what we know about proportions and solve for the missing side. Remember, with proportions, we can crisscross multiply, so we're going to do 31.5 times 4 and then divide it by 18. So 31.5 times 4 first. And I see one number after the decimal, so we're going to place the decimal one number over, and that's 126. Now we're going to take 126 and divide it by 18. So we're trying to figure out how many times does 18 go into 126. When start guessing and checking. Let's try 18 times 7. 7 times 8 is 56. 7, 8, 9, 10, 11, 12. It ended up being 7 times. So the missing side length x is equal to 7 inches. This was from 7th grade math. The next problem is going to be from our 8th grade math textbook. So we have an example with two similar triangles. It says that while playing tennis, Matt is 12 meters away from the net. So here's Matt. He's 12 meters away from the net. This middle line here represents the net when playing tennis, which is 0.9 meters high, and it's already labeled there. He needs to hit the ball just so that it clears the net. So we're going to try to clear the net without actually hitting the net and land 6 meters beyond the base of the net. So we want it to land right here at this corner, 6 meters away from the net. At what height should Matt hit the tennis ball? So ultimately we are trying to figure out how high up should he hit the tennis ball. So we're trying to figure out this distance right here. Now, like I said, we do have two similar triangles. I'm going to highlight them to point them out to you guys. One of the triangles is the smaller triangle here. The other triangle is the larger triangle that you see. They're just combined into one picture. And remember that we are trying to solve for the height of the ball. So again, we're going to do a proportion since these are similar. Remember, a proportion are two fractions that are equal to each other. I usually like to put the smaller triangle numbers on top and the larger triangle numbers on bottom. Now for the smaller triangle, we have to use the 0.9 because it's the height of the net, and then because we're solving for how tall Matt is. We also need to use the 6 for the length across the bottom, because we are also given the longer length across the bottom for the larger triangle. So let's start with the smaller shape first. So let's start with 6 is the length for the smaller shape. Now we actually don't know how long this yellow side is yet. 12 goes from Matt to the net, and then 6 goes from the net to the corner here at which they hope the ball will land. So this total distance, we actually need to add these two numbers together to give us this longer yellow side. So 6 plus 12 is 18 meters total. So 6 corresponds to 18 from the larger shape. And then from the smaller shape, again, the orange triangle, we're going to use this 0.9. And then we're going to leave this one blank because, again, we're trying to figure out how high up should the ball be thrown. Alright, our goal here is to solve for the proportion, this missing number. So we're going to crisscross multiply. So we're going to do 18 times 0.09. And then take that answer and divide it by 6. So let's go ahead and get started. 18 times 0.9. 8 times 9 is 72. 9 times 1 is 9, plus 7 is 16. There's one number after the decimal, so count over once, and that's 16.2. And now we're going to take 16.2 and divide it by our last number, 6. 6 goes into 16 twice. 6 times 2 is 12. Bring that decimal up and bring down the 2. 6 goes into 42 7 times. So I'm getting 2.7. So that represents the height of the ball. 2.7 meters high is ultimately how tall the ball should be when Matt is hitting it. Alright guys, that's similar triangles. We're using similar triangles to solve for missing sides. Remember, to solve for a missing side, we can set up a proportion because corresponding sides are proportional. We also learned that for similar triangles, we have to have two angles that are the same, like 95 and 30. Or in this case, we knew that 145 and 145 matched up, so those are similar. Thank you guys for watching.